0.0.0.0 represents all routes in the entire network. Then the next 4 zeros represent any mask. There is no restriction on the network segment. No restrictions on masks. Because it is the combination of IP address and mask. To define the network segment. Now it can be any network segment. For address and mask are not matched. Including when we go to match in the future. The mask is the longest to match. If now the mask is 4255. It's 32-bit. Then send any piece of data. It must match the route. Default route forwarding. That's wrong. Because 4255 are 32-bit masks. For equipment. It's also 4 zeros. There is a gateway here. The data is forwarded. Now your computer can access the internet. Thanks to such a default route. Other than PC. It will also be used on the company's public network export. Let's say this is the company. This is the operator. Then I want to access all the data on the public network. Such as Google, YouTube, Facebook. They are all public network services. Available through the operator. Forward the data. In company export here. We'll enter a default route. Point to the device that the operator connects with us. That is. In the future. No matter where your data is sent. The traffic is handed over to the operator. Let it help forward. This default route. It is a default route that every company export will have. As long as the company is now using the internet business. There will be a default route. The next hop is pointing to the operator. The export is configured like this. For export. It's just a device. Its configuration is IP route 0.0.0.0, 0.0.0.0, Internet address of next hop carrier and company. Generally speaking, this internet address configuration is the company's side and the operator side. When handling carrier business, it will provide the internet address. If the future uses dial-up internet, such as the form of PPPoE, then it is another form. Then the exported IP is not fixed. If the enterprise handles fixed bandwidth. If there is a public network IP here, there is also a public IP here. Now the most used is a 30-bit mask. That is, only 2 addresses are available under the 30-bit mask. One end for the company. The operator at one end uses the. Just use the next hop to point to the operator. As for how to get back the operator data, we can't talk at this stage. The future IE stage will talk about. A default route points to the past. Don't worry about how it came back. Because this is the configuration of the operator. For business. When configuring, it is to export a default route pointing to the internet address. This address is when doing business. The operator will provide. Okay. Let's summarize the problem of static routing next. When we were configuring in the last class, everyone will find a problem. The overall configuration of static routing is very complicated. It's not that its mechanism is so complicated, but the input on each device is complex. Let's take them as an example. These 3 devices. If I want them to be able to communicate with each other, that is very troublesome. Let me introduce to you. Based on our configuration from the previous lesson. In fact, only 3 PCs can communicate with each other. If you have tested other, you will find R3 goes directly to ping R5. It doesn't work. Because R3 does not have a route to network segment 23. That is to say, R3 can ping the device. That is because it has a route to 192.168.3.100 on it. But it can't ping the left interface of R5. Because it does not have a route to network segment 23 now. If you want to ping the address of this interface now, or ping the right interface of R4, you need to enter another default route here, pointing to the 23.1.0 network segment. All I want to say is, we just let the three PCs communicate with each other. I'm going to be on this device. Both the 2 network segment and the 3 network segment must be entered. I want to enter 1 network segment and 3 network segment on this device. Enter 1 network segment and 2 network segment on this device. You will find I have to do a lot of configuration for each device. Secondly, after configuring, it's just 3 hosts communicating with each other. These network segments are still unreachable. So you want to pass the static route. Ping all 6 devices in the whole network. Relatively complex. There are not many network segments. That's it for configuring static routing. In the future, if in the configuration process, more equipment, it means that you want to connect the whole network. It is very complicated to use static routing. And it's easy to go wrong. And you will find halfway maybe on a device, the configuration of a static route is missing. It may cause a certain device to fail. Suppose there is a 1.1.1.0 network segment here. One day this network segment disappeared. You don't have to worry about how you disappeared. This device may be gone. The business has changed. There is no such segment here. Then I'm going to be on each device. Cancel this network segment information. There may be many routers in the future. You can't say that. This network segment doesn't exist anymore. Static route is still. If a piece of data arrives, it cannot be forwarded. There is no route at the peer end. Have to cancel. So it's a hassle. This is cumbersome from a configuration point of view. Of course it depends on the demand. If you only let the PC communicate. In fact, it doesn't matter whether the middle is connected or not. It does not mean that the host cannot be pinged. Because they do not belong to the same network segment. The specific network segment to go to cannot be reached depends on the routing table. Instead of looking at the middle of these, although the data is forwarded through this link, but it doesn't mean it must be possible to ping the device from here. The data is just passed through. It helps to retweet. As long as this packet arrives on this device. Know the destination network segment. The above are some disadvantages of the static routing we mentioned. The first problem is that if the network is large, the configuration is relatively cumbersome. Another problem is static routing is a very dumb routing. Because static routing, it is impossible to perceive the overall network changes. For example, multiple devices are now interconnected. Connect each other with a line. Now pointing one by one statically. Suppose there is a network segment on this device. Is 1.1.1.0. One day this segment disappeared. If you are not in time on every device, cancel this static. Then it will forward the original. That is, as long as you don't cancel, it always thinks that this network segment is still. Then it means, no matter how a remote network segment changes, the equipment here can't sense it at all. So you have to manually configure. All information can only be maintained manually by the network administrator.